Okay, so let's go on to explainable variation. Okay, have a think about it. I've got one person who put a 4 here. Do you think there will be some groups within the class here that you could classify who would be likely to spend different amounts of time on the course? Like, what classification of student do you think might spend more time? Can anyone think of it? What do you think might, possibly? Do you think that maybe male students might spend more time than female students? Do you think that older students, ones who have come back after being in the workforce for a while, might spend more time than younger students? Or you think so? I think that's probably very true. What about students for whom English is a second language? Would they spend more time than New Zealand-born students? Okay, so all of these are possibilities. So there could be to do with age or whatever. It could be males versus females. What about in the halls or not? Do you think that might make a difference to how much time people spend on Blackboard? Whether they play sport or not. So there could be things that we actually could find out that cause or are associated with different amounts of time spent. And this is called explainable variation. And statistics is all about trying to find out what are the explainable things. One of the things you want to do in manufacturing processes as much as possible and in human processes is to get rid of the variation as much as you can. If you can think about it, if you've got chip packets and you're always overfilling them in order to make sure that none of them are underfilled, you're wasting money because you're putting too much in them. You want to reduce your variation. If you're trying to plan how to build a building or the time it's going to take, you want to reduce the variability of all of your tasks so that you can actually just see how long the job is going to take. Reducing variability is very, very important in a lot of processes in business. And so you want to find out what things can you control for. So we don't know for sure if these things affect them, but there are tests to do it. So for instance, if I'd asked you to write down M or F, if you're male or female, or 1 or 2 or 3, whatever year you were, I could then take these and find out and see, is there a relationship between what year you are, or if you're male or female, and the number of hours that you spent. And that could be a useful piece of information because it could be used to help to improve the learning for some group. Okay, so then there's another one called sampling error. So I take 5 pieces of paper and I'll take them, here's one, and here's another one, and another one, and another one, and I'm just taking them at random. Okay, what have we got here? Shall I use this one or get a new one? So I've finished that one. Okay, so what have we got here? Oh, I don't like that because it's a fraction. Never mind, I have to use it because that's my sample. Okay, so let's see what they say. We have 4, 0, 9, 2, 3, oops, and the other one, sorry. Or maybe I'll take that 4 out, that was my original, so a half. Okay, so we have these 5 values here. Anyone tell me what the mean is? Anyone got a calculator on them? Okay. 0 plus 9 plus 2 plus 3 plus 0.5 equals, divided by 5 equals 2.9. Okay, so the mean for those 5 was 2.9 hours. So can I then say that the mean for all of the room is 2.9 hours? Well, hands up those who think I can. Hands up those who think I can't. Okay, can somebody tell me why not? Exactly. Okay, what about if I take another 5? 1, 2, 3, 4, 5. Okay, so we've got 4, 3, 3, 4, and 3. Okay, So we've got 9 and 6 is 15, divided by 5 equals 3. So the mean is 3. That's interesting. It's quite close to 2.9, but it's not the same. Okay, if I took another sample of 5, would it be the same? Probably not. But it would not vary as much as the actual numbers would, which is a very, very important principle. It's called the central limit theorem, and it says that the means that you take, the means of samples, won't vary as much as the sample itself does. And the central limit theory actually tells you the difference between the two. Okay, the reason they are different is because they are samples and not the population.